Great. Great to be here on stage. Great to be here in Berlin again. We are talking about optimizing GraphQL delivery in AEM. You just heard Dragan and diva-e talk about the front-end aspects, and now we're going a bit into back-end parts of it. Who are we? My name is Georg Henzler. I'm a solution architect. I always say, like, I try to make the AEM or like the Adobe product stack to deploy it as well as possible to the customers. I also see some customers in the audience that I have worked with, which is great. And
I'm Evgeny Tugarev. I work for Adobe in the sites team. So yeah, this is what we do. First time presenting here on adaptTo and first time on stage, so please be gentle.
Yeah. And it is also great to meet the people in person. So diva-e, Dragan, Evgeny and myself, we have worked on the client, but Dragan I know from the same company, so I had met him in person, but diva-e and Evgeny not, so that is great to eventually meet people. This is, okay, why are we here? What are we trying to tell you? What's in for you? So AEM, there's some improvements in the AEM backend engine in GraphQL to make it more performant. Performance is always good, as we know. We want to discuss some best practices around architectures, like something was already mentioned. We say it again, it's always good to hear it twice from different people. And there is also this Java variant of the client library that I'll demo. Let's see how that goes. But first, I hand over to you, so you can talk about the current state of GraphQL.
Yeah, thank you. So since the moment of introduction of GraphQL delivery in AEM, a few years have passed. So we saw the trend that GraphQL is actually actively used for content delivery, and it goes very well for most of the clients. But sometimes customers actually get back to us, and the question that they ask is basically the same question, and it is, why is it so slow? So we actually analyzed a number of our customer queries, and what we discovered is that most of the time it is because of ineffective filtering or pagination, or it might be the absence of both. So all this lead to the initial result set size. So I'm speaking about the number of content fragments that has to be retrieved first from the GCR, and then due to lack of filtering, paging, it will transfer to large result set size, which is had to be transported back to the application. So that was the main pain point, and here I'm here to provide you some recommendations how you can avoid that by implementing filtering and pagination. So I basically talk a little bit about best practices, because I think it's really, really important. So what we have to offer. So we have a thing which is called hybrid filtering. What it is in essence. In essence, hybrid filtering, it's GCR-based filtering from one side and AEM-based filtering on another side. So first, then you, well, basically when you execute your GraphQL query, you always have some GCR query which runs in the background. And this is actually where results are getting filtered first time. So, and this is very important to make sure this initial result set size is not very big. So it's basically the opposite. It's better to keep it as small as possible. Second technique that you can use and should use, it's basically a pagination of a result set. So if for some reason you don't use any hybrid filtering or not filtering or AEM filtering or GCR filtering, the pagination is your only resort actually to limit the result size, which will be then transferred to the client application. And the last, but also very important, we have a procedure of updating content fragments in order that you can benefit the new index and new structure and basically faster content extractions from GCR and faster content delivery to the customer. So, as I mentioned, hybrid filtering provides better performance by combining GCR and IM filtering. So, in addition to that, it is also important to filter on the path and leverage the content structure, leverage the structure of your content fragment. So it may sound a little bit vague, but what I'm talking about is that it is always good to keep your content structure. For example, for wknd application where we have articles and adventures, it would be better to use specific folders to keep those content fragments in different places, basically. Well, it's the same concept as if you have a lot of eggs, it's better to use several baskets to just keep them. And with that, if you keep your content fragments more or less separate, you can leverage the filter on path and add a more specific location to your in your filter expression, which will then be used in the GCR query. And of course, this is not the only way you can limit the initial result set. You can also combine this path criterion with other criterions together with AND. Yeah. There is also a limitation. Not everything can be filtered in the GCR, and there will be a reference. We will link on the reference page where you can read all in detail what can be and cannot be filtered, actually. But to name a few, if you use, for example, ignore a case word in your filter expression, this one will not be filtered on the GCR. And also, if you use something like contains not and filter on null values, this is also cannot be filtered in the GCR query. So this will go to IM filtering and apply to the result set to reduce it further, and then it will go to the application who requested it. So here you can see how filtered query could look like. So as you may see, there is a slash on the value. So content dump in the shared magazine. This is needed to make sure that the number of reduce will be only the content fragments which actually contain inside the magazine folder. Without the slash, the query engine would first analyze all the content fragments which is inside EN folder, starting with a magazine in the node name. Yeah. So there are two types of pagination. So I just showed the list query, but actually, yeah, this is how it looks like. And important thing is that list query is using, it's a feature, it's using limit and offset pagination. So how does it look like on the example? So here's your query. You want to read first, you want to read 5 results, starting from a 5th element. So that would mean that fetcher still need to fetch and skip first, discard first 50 results and deliver only 5. So it may be fine if you read from the beginning of your data set, like first 5, but if you need to read more pages, if you read from 100 items and more, that would cause performance drawback. So to overcome the issue, there was a specific query type. I think you've seen it already, was introduced, which is paginated query. So basically, it's more or less the same thing, but it has slightly different syntax, because paginated queries actually adhere to GraphQL cursor specification, and it uses cursor to navigate through result set. How does it look like? So with every so basically you have a page info, and you also have a property which is called cursor with every item which you with every page and item which you actually request, and you can leverage this property to make sure you only get the results what you're interested in. So the paginated query fetches, in this example, only 5 results starting from the cursor. And the cursor is actually something which we specify in a query. So yeah, so this is beneficial that it doesn't have any performance drop with a large result set when you need to read the data towards the end of your result set. So we recommend that you use paginated query whenever possible. Yeah, this is more or less summarizes what I just mentioned. And with that, stage is yours.
Okay, so now I want to demo the client. Maybe just a last word about this limitations. So there are some things that will go through JCR and some not. And maybe even in 2 years, like there's more that goes to JCR. So use the tooling to see what actually ends up, what query is generated. That is good. Now about the demo. So we saw the JavaScript client already. So this is a Java client. You could ask, why would I need a Java client? Because maybe GraphQL is only for the browser. Yes and no. Most prominent use case is probably the browser, but you can also have backend-to-backend integrations. So the client is also deployable as bundle. But the other case is obviously Android. It works also very well with Android. Now, let's see how things work and if they work. Demo is always a great time. I mean, you saw some code already, how it looks in JavaScript. So yeah, you see some imports that I created already. Yeah, let's get started. I need to connect to AEM from maybe, yeah, I should actually. Okay, demo. So what I quickly wanted to show. This is a very simple Java project, and mostly it has a very simple dependency, so no big package attached. It is just one simple dependency. Obviously, this is a simple client, which is for quickly getting started. There is also a Apollo Java client, like if you have very advanced use cases and you want to do very fancy things with GraphQL on the client side, then you probably should use the Apollo client, but this helps for this specific use case to quickly get started. Now, okay, now you can also see it, which is great. So how would I do it? So I just start and create a client, and and it uses the builder pattern. And what would I need? You see already there's quite some things. One of the more important things to specify here is the endpoint. And because I don't want to type it, I just copy it over from the backup file. Right. And yeah, we can arrange it like that. And we need some auth. Obviously, there's also there's token authentication. That would be more something for production, but easy enough. We have a local host with admin, and we just build this. And now I have a client. Now for this simple use case, I mean, normally you don't do this in production code, obviously, but we can just do this. So far it's not so very interesting, but yes, there is a client. What can we do with it? So what we could do is just we could just run a query, and you see there's a few overloaded methods. But let's use, we also have like a GraphQL object. So let's use that GraphQL object. It's again the builder pattern. And now the nice thing is we learned about how you use list, paginated, and these different options. The nice thing here is you can just give like a name. So we can just say article, and it actually did some neat autocomplete here. But just to show this again, so yeah, it's the builder pattern. It just provides with the things I can do. I can have like a field. I can also have a filter. Show this in a bit, but and you can also have like sub sections. But let's start simple. So a field, and let's use title. And we can build that for now. And then we can run this thing. So we have the client, and we say run query. And you see you also have the possibility to, yeah, but obviously I need this in a variable. And then I can just do it like this. Okay, and with this I get a response, and that response I can just print. Easy enough. So that should work. Let's see if it actually does. Yes, it does. Easy enough. You also see, yeah, how you get this. Now, there's also a so now we can yeah, just, and also just to show, obviously, if I like, this is now dynamically generated.
How many times do we have? Because
I can also just have the path if I only needed this. So this is easy enough to create. Right. So I prepare the example with filtering. And it's also a bit more complex because like just showing like some more things, I hope you can see the code. It's also a bit more complex because it uses a sub-selection. So this is something that you have to import because it doesn't work with chaining. So you can have the author fragment. And you see here you have like first name, last name. And I can, I have a filter defined on the path, again with the starts with. So I probably should do what Evgeny recommended here. I have a sort by, and I build it, and I can just also print this response. So if you look at this, not the right shortcut. Right, you see this. So this is filtering now. Now I can also say, well, I just want this part. Then I'll obviously don't. I think I did something wrong. Anyway, you get the idea. Let's try it like this. Yeah, so now I have exactly one as I expected. So that's important. Obviously, first we want to filter, like in local demo environments, like it's often like you don't have much data, it doesn't matter, then you just get it. But filtering is very important. So really make sure you have a good concept on how you filter your queries. Then and then we have the paging, and I just quickly, because like we also don't have that much time. So I want to quickly show how we can page with the cursor. So if you look at this code, so the starting code is easy, but the main difference is this paginated. The other things is fairly similar. We also have a page size that we then give along with different methods. So we create the paging cursor, and here we just, while this cursor has more elements, we just iterate through it. Maybe like a thing, so you can also use JSON mapping. So for that, just to very quickly show this, it's very easy. You can just create pochos and you annotate them with JSON annotations. So they just then magically work. So with the paging curve, just quickly showing this, and now with this, you'll also notice that the response looks a bit different because this is a pocho and the toString just looks like that, so it's a bit more condensed. And just quickly want to show the difference to, like, if you do it with the offset and limit, first of all, it's not recommended for performance reason, but it also gets, like, from the code, it gets more complicated just because it has to be, you have to keep track. So this is now, I mean, there's different styles of doing it, but you already see this is, you know, like these fancy for loops with, assignment in the for loop. This is the shortest way to do it, but there's other ways. But anyway, this is nicer to do. Now, with that, and also because it took a while to get this running, let's go back to the slides and to the content fragment update, right? So these slides I leave as reference for you, but I hand over to you again.
Thanks. So let's talk a little bit about content fragment update, what it is in essence. So what is in it for me? So by using content fragment update, you will leverage the auto-indexing of all your properties of content fragment, enable better performance for filtering, paging, and it is also backward compatible. But first of all, why is it needed? So some time ago, maybe a year, maybe a little more, we actually became a requirement that content fragments has to be, customers who create models and define properties want to search for these properties inside the content fragments. This means whatever is defined has to be found. So, and here came the question: how you possibly filter on property name if you don't know the name of this property? So, because content fragment models are defined by customers, we don't know in advance what the name will be. But hopefully, the solution came from GCR itself, and this solution actually was by leveraging regex expressions with the index definition in the property index property definition. So let me give you some ideas how it was when implemented. So we had to create, actually, for that improvement, new index which is called content fragments. So for historical reasons, content fragments are also assets, but with that requirement, we could not really leverage what we index which we currently have, which is called fragments, and make sure there will be no collision in the future between assets and content fragments. So for that, we created a new index which is called content fragments, and it actually indexes a new property So it's a new mixin interface type, which is called DAM indexed fragment data. So, well, I'm happy we actually introduced this property because it's really only the way how we can guarantee that content fragments will meet requirements that customers may drop on us in the future. So, it also, when you edit a content fragment in the editor, it creates a new node, which is called fragment data, which duplicates some of your property in a content fragment. This is actually the sacrifice we had to make. And once your content fragments are updated, you will see a new property which is called content flag CF global version, which will reflect the current state of content fragments after the update process has been completed. So let's look on a few screenshots. So on the top screenshot, you see how this index actually look like. You see there's a number of, so first it indexes on the DAM indexed fragment data. And there is a properties which call string values, long values, and so on values, and also UUID in the end, which is basically the ID of a content fragment. And yeah, so on this screenshot you see, so basically when I edited a content fragment in the editor, it just added the new mixin type to index data, master, which is variation. And you see there's string, then add main. So this is specific notation, which actually you can see why it is like that. So it's on the top. So the name is actually a string identifies the type of the property. So with that, we can actually, and then comes actually the regular expression, which is basically everything. So with that property definition for the indexing, we can effectively index the property names which customer are defining, which we don't know in advance. Yeah, so and one benefit which is which this brings, since it's a new index and it's only specific to content fragments, the index size is much less compared to fragments index, which is more or less a smaller version of DAM asset lucene index, and therefore the performance is of course better, and yeah, we can index all the properties. Well, I would say this would cover 99% of scenarios. If at some point you would like to feel like you want to add something to this index, let us know, and we will probably do it for you. So the team will review, and we'll probably yeah, update this index so all customers can benefit from that. And yeah, the last topic is, okay, there's a lot of things going on. What API shall I use?
Exactly. And yeah, so we touched that a bit. So we have, first of all, always use higher level APIs. That is always true, whatever you do. So there is a HTTP API. So there's also, like we talked a lot about GraphQL, but there's also the REST API for manipulating content fragments that also Dewey showed earlier. Make sure that you use those. You have also a content fragments API in AEM. It's also referenced on how to use this, so you can also use it in the backend. Don't use Sling and JCR to manipulate content fragments, because then you might get something wrong. Yeah, but let's move quickly on to the next point, because we don't have that much time left. So quickly, sound architecture for better performance. So to sum up what we all talked about. So
yeah, well, first and foremost, you optimize your query, apply filtering, limiting, use pagination, always make sure that you request the only amount of data which you want to digest. Because with GraphQL, you can have a lot of nesting levels, and each nesting levels actually adds to the processing time. Important thing is also perform content fragment update. We actually encourage you to do that, to benefit from the latest improvements we introduced recently. And of course, persistent queries, it's a must, very good for you. And
yeah, I can add something to that. And the content fragment update is really something you have to do. So it doesn't happen automatically when you install a service pack upgrade. So look at the references. But let's talk quickly about persistent queries. So in general, we recommend them, obviously, because they can be cached, because persistent queries are GET requests. There is a bit of a tricky situation with a course that you need in browser together with the caching, and just quickly going through this because there's different options. So basically, you can configure course in AEM, you can configure it in the Apache core via standard Apache means. You can also do it in a CDN usually. So what do we recommend? First of all, like AEM, you can configure it. It's good to have it for development purposes, but it's not that great for caching. Just use the response caching from the dispatcher and add the course headers in the Apache core. There's also in the references on how to do that. There's very simple ways, like a 3-liner, like that you often find for other platforms. Like there is a AEM. For AEM, there's a documentation a bit more, bit more capable to ensure to cover all cases. So follow that documentation, that is great. You could, so that is obviously optional, so you don't need to bring your own CDN because Fastly is always there, but you could, if you wanted, you can also configure it in CDN. So just make a well-thought choice in that regard, and then you're all set, and you can cache it nicely, and also the dispatcher the course headers are set correctly. Yeah, with that, and also because of the time, just references, you can look that all up. So, I mean, as I mentioned, the content fragment update. So we have that all collected for you. Now we're done, and Roman is already eagerly waiting to get some questions out.
Yeah, we're already in overtime, so unfortunately, we had some technical issue, but that can happen. So we're just going to go for one question. The rest can be answered afterwards. So can't you also make use of occlusion indexes to speed up your GraphQL queries?
Well, I guess this we have to discuss with indexing team, but I'm not sure it's actually possible to use multiple indexes at the same time. So it's possible. It's definitely possible to use one index, but not sure about.
It would fit the best suitable one, I suppose. But like our recommendation is stick to the standard, because like the good thing about the setup now is that by default, without introducing a custom index, usually you're fine, and that should really be that what you. And if you have a very special use case, then think about custom indexes.
Let us know.
Okay. Thank you, Evgeny. Thank you, Georg.
Thanks a lot, guys.